Hello, thank you for watching this video. So in this video, we're doing question 4 of November 2019, question paper mathematics paper 1. And the topic is functions. So behind me, I have a parabola, which is f, and this hyperbola g here. So I'm going to read a question 4 statement and then answer the questions that follow. So let's go. They are saying, below are the graph of f of x is equal to x squared plus bx minus 3, and g of x is equal to a all over x plus p. So they are saying you have these two functions, f, you can see f with this equation, x squared plus bx minus 3. And this function g here, the red function, which is defined as g of x equal to a all over x plus p. No problem. They are telling you now that f has a turning point at c and passes through the x-axis at 1 and 0. They are saying this parabola f here have this turning point at point c, right? And it also passes through the x-axis at point 1 and 0, which is the coordinates for the one of the x-intercept of f is 1 and 0. Fine. They are saying D is the y-intercept for both f and g. So there's a point D here. Can you see it? This point D is the y-intercept for both function, the red function and the black function. No problem. They are saying the graphs of f and g intersect at e and j. They're saying the two functions f and g, they intersect at e and j. But those are not the only intersections. There's 3 intersections. There's this one here, there's this one there, and that one over there. So, but those two e and j are just, we're told that they are intersections. Fine. They went on to say that the vertical asymptote of g passes through the x-intercept of f. They are saying g, which is your hyperbola, have a vertical asymptote. Here is it, the green one. It passes at the x-intercept of what? Of f. We're told that the x-intercept of f is 1 and 0, which your vertical asymptote passes through 1. Are we clear? No problem. So at 4.1, they are saying determine the value of p, right? So now we're going to do 4.1. They want you to write down actually the value of p. This is 4.1. They wanted to find the value of p. What is p? P is this value here. And this value here, you know very well it is related to your vertical asymptote, right? So you are given g of x to be equal to a over x plus p, right? No problem. You know it is related to a vertical asymptote, or you can say it's your horizontal shift. Are you with me? So in that case, your equation of the asymptote, your asymptote passes through 1. Your vertical asymptote passes through 1. So you know the equation of that asymptote is x is equal to 1. Right? So the equation of the asymptote is x is equal to 1. Then you can transpose the 1 to the side. Then you have x minus 1 is equal to 0. So this part here is exactly that part over there. So your g of x is equal to a over this part, which is x minus 1. So your p is this number here. Therefore, your p is equal to minus 1. It's that number over there. P is minus 1. There is your p. Is it clear? No problem. Then we move to the next one, which is 4.2. At 4.2, they are saying that show that a is equal to 3 and b is equal to what? Is equal to 2. They wanted to show that a is equal to 3 and b is equal to 2. What is a? A is this number here, right? Belongs to this hyperbola here. So you're given that g of x is equal to a over x, but we found that it's x minus 1. Are you with me? So it's x minus 1, which is what we have there. Then, what they want us to find, the value of a. If you have an incomplete equation and you're missing one position, or you're missing one value, you can use any coordinates that you have on the function to try and find the missing number or coefficient, whatever that you need. So in this case, we need a. But in order to be able to find a, we need at least 1 point on the function. So we can have x and y. We can have 1 point x and y. We can substitute the x there and substitute the y there, and then a will be left as an unknown on its own. So in that case, what do we have? Do we have e? No, we don't have. Do we have J? No, we don't have. Do we have D? Possibly, because D, F and G, they both intersect where? At D. Are you with me?
Yes.
F and G, they both intersect at D. And you know that along this line, x is equal to what? X is equal to 0. Are you with me?
United?
Yes.
Okay.
Along this line, x is equal to 0. So on a function f, which is what you have here, if you substitute your 0, then you will be able to find the y coordinate of D.
Yes.
So in that case, say okay, f of x was given as x squared plus bx minus 3. Are you with me? So we know at D that x is 0 because x lies along, or x along this line is 0. Are you with me? So in that case, if you substitute 0, we're going to find the corresponding y value. So what do you say? Say f of 0 is equal to 0 squared plus b times 0 minus 3. We get that this is equal to minus 3. So we found that the y value at D is equal to minus 3. So this is a y value for function f, which is the same as that of D because they both cross the same position. So in that case, the coordinates of D is 0 and what? And minus 3. Those are the coordinates of D. So what do we do here? So now that we have a point 0 and minus 3, we can substitute this point on G, because this is the y value and this is the x value. And then we'll be left with one unknown, which is what? Which is A. So in that case, we have minus 3 is equal to what? It's equal to A over x, which is 0 minus 1. So we have negative 3 is equal to A divided by negative 1. So it's negative A divided by negative 1 both sides. Therefore, A is equal to 3. Therefore, yeah, you have A there. It's equal to 3. So if you want to write your full function now, you can say therefore your g of x is equal to 3 over x minus 1. Right? We're done with the first part. So we found, we've shown that a is equal to 3. Now we need to show that b is equal to 2. It's the same procedure because we are given that f of x is equal to x squared plus bx minus 3. On this equation, you're only missing one coefficient there, which is just b. You need 1 point on this function, right? And substitute here. So you have d and you have 1. Are you with me? What happens if you substitute d? You see that your b will disappear, because if you substitute d is 0 and 3. If you put your minus 3 and put your 0 and put your 0, your b will disappear. So there's no point of using that one because it destroys the value of what we're trying to find, right? So let's use the second one, which is 1 and 0. This point over here, it's 1 and 0. So the coordinates 1 and 0. Substitute them here. Your 0 is equal to x squared, which is what? 1 squared plus b times 1 minus 3, right? So this will become what? It's called 0 is equal to b minus 2. Therefore, your b is equal to 2. As they wanted us to show, we've shown as they wanted. So we're done with this one. Then we're going to move to 4.3. Is it clear?
Yes.
Because we've shown A, we've shown B. Or maybe we can say therefore, your f of x now equal to x squared plus 2x minus 3. That's all we have. Now, going to move to 4.3. At 4.3, they want you to calculate the coordinates of C. What is C? C is the turning point of a function. Alright?
Yes.
C is the turning point of what? Of a function. There are many ways to do this, right? One way, you can say, okay, this is 4.3, right?
Yes.
My x is equal to negative b, x coordinate of the turning point, called negative b over 2a. That's the x coordinate of the turning point, right?
Yes.
Which is what? which is equal to negative b, which is negative 2, right? Over 2 into 1. Therefore, your x equal to minus 1. That is the x coordinate of the turning point. Now, to find the corresponding y value, you substitute that x coordinate on your equation of f so that you can find the corresponding y value. So you say, okay, my f of minus 1, this is the y value, is equal to minus 1 all squared plus 2 minus 1 minus 3. What is an answer to this?
Minus 4.
It's minus 4. Therefore, our coordinates for C is minus 1 and minus 4. Are you with me?
Yes.
Another way you can do this. You can say, okay, I have f of x here to be given by what? By x squared plus 2x minus 3. Are you with me? So what we can do, if we derive this, the derivatives give us a gradient at a point. Are you with me?
Yes.
The derivative f prime at x is a gradient at a point x, right? We know the gradient at this point. The gradient at this point is 0 because at a turning point you can only draw a horizontal tangent. And if your tangent is horizontal like this, it has the same slope as the x-axis. You know that your gradient is a measure of steepness, which is the measure of your slope. If it is horizontal, there's no slope, which is your gradient is what? Is 0. So in that case, what we can do, we can say f prime at x is equal to, derive this, it will be 2x plus 2. Are you with me?
Yes.
Fine. What is f prime? F prime is a gradient at a point x. What is the gradient at the turning point?
0.
So we can substitute 0 here and find the x values that gives us a gradient of 0. So we can say 0 is equal to 2 times x plus 2. So minus 2 is equal to 2x. Therefore, your x equal to minus 1. There is it. So to find the corresponding y value, you put it back there, like you did here, and you're done. Of course, there are other methods as well, but in that case, we're not privileged enough. If we had maybe 2 points that lie on the same line, we're just going to find the midpoint between them, but we don't have that, so this should be enough. So we're done with this question. We're going to go to 4.4. What are they saying at 4.4? At 4.4, they are saying write down the range of a function f. They want us to write the range of our function f. The question is, most important question, what is the range? The range is the set of y values that this function uses. Are you with me?
Yes.
Which y values is this function uses? That's what you need to define. So you can see that your function uses all the y values, because look, we know the coordinates of here is what? Is minus 1, right?
Yes.
And this one is minus 4, because it's what we just found there,
Yes.
the coordinates of C. So this function uses minus 4. So use minus 4 and all the values that are above, because for each value that is here, you can always find the function. Are you with me?
Yes.
For example here, there's no function here, right?
Yes.
There's no function down here. So your function uses all the y values from minus 4 going up. So your y value should be above or equal to minus 4. They should be from minus 4. Are you with me?
Yes.
So in that case, what we can say, okay, this function uses the y values from minus 4 up to positive infinity.
Yes.
So we can say our y is an element of what? Square bracket, which is including minus 4 to infinity. Right?
Yes.
Or positive infinity. Or you can just say my y value should be greater or equal to 4 minus 4. Which is, it should be minus 4 or above. It should work. That is your range. And now we're done with 4.4. We'll need a bit of space to do 4.5. So I'll clean the board and then we do 4.5. Okay, so now we continue. We're doing 4.5. They are saying, determine the equation of a line through C that makes an angle of 45 degrees with a positive x-axis. Write your answer in the form y is equal to. Right? They want you to write an equation of a line through C that makes an angle of 45 degrees with a positive x-axis. They want you to write in the form y is equal to. So they want you to define an equation of a straight line, right? That passes through C and makes an angle that have an angle of inclination of 45 degrees with a positive x-axis. So let's say here is C, right? And let's suppose now we're trying to draw this line of ours. We don't know how it looks like, but we just want to have an idea. Let's say maybe look something like this. Are you with me? So makes an angle of 45 degrees with the x-axis. So if you want an equation of a line, we know an equation of a line is y is equal to mx plus c. What is m? M is the gradient, right? Yes. So on a normal day, you would like to have 2 points to be able to find the gradient, right? Yes. Are you with me? Yes. You would like to have 2 points to find the gradient. Are you with me? Yes. No problem. But this is not the case here because you don't have 2 points on this line. You just have 1 point, right? But what you are told the angle that this line makes with the x-axis, with the positive x-axis, right? Yes. That line gives you your gradient because it is the measure of steepness. The bigger that angle, the more steeper the line. So if you want to find, if you're given an angle of inclination and you want to find the equation of a line, you say, okay, I know my gradient will be equal to the tangent of theta, where your theta is your angle of inclination. Say, okay, my gradient of that line is equal to tangent of what? Of 45 degrees. What is the answer to that?
8.73.
It is 1. Tangent of 45 degrees is 1. What are you getting?
45.
Yeah.
Yes, you are right.
Yeah. The tangent of 45 degrees is 1. So your gradient is what?
That's 1.
It's 1. So we can substitute our gradient back there. It's okay. Our function y is equal to m, which is 1 now because the gradient, x plus c. Now that you need 1 point, like you did with the previous questions, just need one value of your function or of your equation. Just take 1 point that is available, which is the coordinates of c, and you're told, or you calculated the coordinates of c to be -1 and -4. Substitute these points, your y there and your x there. So your -4 is equal to -1 plus c. Therefore, the c is equal to -3. Are you with me?
Yes.
So, God is okay. Y is equal to x minus 3. So, this is the equation of a line through C that makes an angle of 45 degrees with a positive x-axis. Is it clear?
Yes.
No problem. Then now, we go to the next question, which is what? 4.6. What are they saying at 4.6? At 4.6, they're asking, is the straight line determined in 4.5 a tangent to f? Explain your answer. So they're asking, is this straight line that you have here a tangent to f at this point C? They're asking this line here, right, the green line. Is it a tangent to this function?
No.
It is not. Because a tangent at that point, right, like I said in the previous question, a tangent at that point will have a horizontal gradient. Your gradient at a turning point is 0. So all tangents, right? All tangents, what am I saying? All tangents that, what am I saying? All tangents at a turning point of a function will have a gradient of 0. Since this one have a gradient of greater than 0 or not equal to 0, then it is not. Is it clear?
Yes.
So, in simple terms, we can say, is the straight line determine a tangent to f? You can say no. How many marks? So you want us to explain. No. y is equal to x minus 3 is not a tangent. Are you with me?
Yes.
A tangent at a turning point, right, of a function have what? A gradient of what? Of 0. Are you with me?
Yes.
You should have a gradient of 0. But the gradient of y is equal to x minus 3 is what? Is 1. Therefore, 1 is greater than 0. Or your 1 is not equal to 0. Because in order for this line to be a tangent, this gradient should be 0.
Yes.
Because that's the only way it will cut there without cutting your function multiple times. Not sure if that makes sense. Okay, so now we're doing 4.7, right? 4.7 reads as follows. They are saying the function h of x defined by f at m minus x plus q has only one x-intercept at x is equal to 0, right?
Yes.
Determine the values of m and q. I'm not sure if you are following. They are saying to us, the function h of x defined by f at m minus x plus q has only one x-intercept, right? At x is equal to 0. Determine the values of m and q, which is they want us to find the values of m and q. Let me just write this function. So this function of ours is what? Is h of x. Are you with me? Defined by f at m minus x plus q. Are you happy with this?
Yes.
That means this function is obtained by transforming f this way. Are you with me?
Yes.
By transforming f this way and that way. I'm not sure if you get what I'm trying to say.
Yes.
So h is obtained by transforming f this way, which means whatever that you did here and whatever that you did there. So they want us to find the values of m and q, which is the values of that transformation of yours. Are you following?
Yes.
So what they told us, what is very important, they said that this function h, right, has only one x-intercept. It has only one x-intercept where at x is equal to 0. So they're saying this function, the new function, have only one x-intercept at x is equal to 0. If it have one x-intercept at x is equal to 0, which means you know your function is a quadratic function, right?
Yes.
Your roots for a quadratic function can be equal, unequal, or they cannot exist. They can be non-real. They'll be equal, unequal, or non-real. So in this case, if they're saying this function have only one x-intercept at x equal to 0, what that means, it means your roots are equal. Are you with me?
Yes.
It means your roots are what? Are equal. And if your roots are equal, the only way they are equal, because you can look at these two roots, are they equal or unequal?
Unequal.
They are not equal because one root is negative and the other root here is positive.
Yes.
Which is x-intercept, one x-intercept is negative, the other x-intercept is positive. So these two roots are unequal.
Yes.
The only way for your roots to be equal graphically is if your function tends there at 0. Because we're told that one x-intercept that you have, are you with me? You're told that one x-intercept that you have is here at x equal to 0. So what do? You can plot it and say, okay, this is how my function will look like. This is x equal to 0, this is y is equal to 0. So at here at x equal to 0, that's where the equal rows are, which means our function is turning like this here. Here at 0 and 0. Because we're told that the turning point is sitting at that point. Because when they said to you, h has only one x-intercept at x is equal to 0, the x-intercept will be sitting there at 0 and 0. So your coordinates there for the x-intercept is what? 0 and 0 is at the origin. So they want you to find the value of what? Of M and Q. So how do we do this? Anything with a turning point, it's easier to deal with it using turning points. So which means we were given F, because I know the natural thing that one would like to think, they would like to do and say, okay, h of x is equal to f at x minus x at m minus x, right? So one will say, okay, what is my f of x? My f of x is equal to my h of x. F of x is equal to what? X squared plus 2x minus 3, right?
Yes.
So if you're finding your h of x, you know, if you find your h of x, on your f, you must put that m minus x.
Yes.
So it will be x, it will be m minus x all squared. Do you agree?
Yes.
Plus 2 into m minus x all squared. Do you agree?
Yes.
Minus 3. Do you agree?
Yes.
And then you add the q at the end. I'm not sure if you're following me.
Yes, I'm following.
Are you following me?
Yes.
I don't think that we should be having a squared here. Are you happy?
Yes.
Are you happy?
Yes.
Okay. In that case, also we can just say, okay, it's fine. You can say, okay, h of x is equal to what? Let's leave this as is,
Okay.
which is m, because it's not important. We're talking about turning points here. So this part is the one that will bring us the turning point. So m minus x all squared plus 2m, right? Plus 2m minus x minus 2m, 2x. Do you agree?
Yes.
I'm multiplied by this in here. Minus 3 plus q. It would be nice working with this, but this will be very complex to work with, to be honest. Because you're dealing with the turning points, so it's better if you go and find the turning points.
Okay.
Which means write this thing so that it has some sort of turning points, which means write this thing, your f, write your f of x in the form a into x minus p all squared plus q. Write it this way. Because if you write it this way, you can do this without problems. But this way it's going to be very complex. I'm scared of it, so I'm stopping here. Are you following me? Are you following me?
Yes.
Or it can be done still, to be honest. In all honesty, it can be done. Do you want me to continue doing it that way?
Yes.
Okay, let's do it that way first, before we go to this one. If we get to that one, depending if you are happy on what. So let's continue with this method and see how far it will take us. So let's say now h of x is equal to m minus x all squared. Do you agree?
Yes.
Plus 2m minus 2x minus 3 plus q. Do you agree?
Yes.
Okay. We know the x coordinate of turning point. The x coordinate of turning point is minus b over 2a. Do you agree?
Yes.
Your x coordinate of the turning point is minus b over 2a. But in that case, we will have to expand this as well. Because here you will have another thing of x that you need. So do you want us to expand it? So we'll say, okay, h of x, I thought we were going to skip it. It's called m squared, right?
Yes.
If you multiply this bracket out, minus 2mx, do you agree?
Yes.
Plus x squared plus 2m
2m
minus
2x
2x minus 3 plus
q.
plus q. Do you agree?
Yes.
Let's group the like terms together.
Okay.
The only square is this one. So your h of x is equal to what?
X squared.
X squared. The things that contain x is this one and this one. Do you agree?
Yes.
So it's going to be minus 2mx, right?
Yes.
Minus 2x. So we're done with both of them. And then the rest, you can just add them. Plus what? plus m squared. Do you agree? It's a number,
Yes.
m squared. M squared is a number.
Yes.
Plus 2m is a number. Do you agree?
Yes.
2m is just a number.
Yes.
Minus 3 plus q. Let's count these things. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have all of them there. Are you with me?
Yeah.
So we want to calculate the value of m. So let's use this part, because this part is the one that will give us the turning point, the x-coordinate of the turning point. And we do have the x-coordinate of the turning point. The x-coordinate of the turning point is what? Is 0. Because that's where we only have one root of this equation, of this quadratic function. So what we're going to do, we're going to say, okay, h of x is equal to x squared. I want to take out the x so that you can see that be x part.
Yes.
So let's say plus, I'll put bracket, minus 2m here. Minus 2, are you with me?
Yes.
And then I'll put the x out here. Do you agree?
Yes.
Plus m squared plus 2m minus 3 plus q. So this part is the part that gives us what? X coordinate of the turning point.
Yes.
We said the x coordinate of the turning point is equal to negative b over 2a. But we have the x coordinate of the turning point. What is it? It's 0, because that's where that x-intercept is sitting. Because it's turning here.
Yes.
So we can put it here and substitute our b and our 2a and try to solve for x. And try to solve for m. So x coordinate is 0, equal to b, negative b. What is your b? And this thing over here. I just hope we did it correctly. This times this, xm minus 2xm. Okay. So minus 2m, right? Are you with me?
Yes.
Minus 2 all over 2 into 1. Do you agree?
Yes.
That case, what do you have? You have 0 is equal to, this time this is 2m plus 2 all over 2. Do you agree?
Yes.
So you can divide by 2 both sides or just cross multiply. It's up to you. What do you want us to do? Let's cross multiply. 2 times 0. 2 times 0. 0 is equal to 1 times that, so it's 2m plus 2. Take the 2 on the other side.
Minus 2.
Sorry?
Minus 2.
It's equal to 2m divided by 2 divided by 2. Therefore your m is equal to
Minus 1.
minus 1. Are you with me?
Yes.
Or. Yeah, we're done here. M, but we need what? We need Q. Are you with me?
Yes.
We need a what?
Q.
A Q. So what we'll do, we'll go to the first equation here. We know one point at H is this one. It's 0 and what? It's 0 and 0. Our Y is 0.
Yes.
Our X is what?
Minus 1. Oh, not m. Okay, sorry.
Our X is what?
0.
Is 0.
Yes.
Then we'll substitute the minus ones. We'll have to write one thing.
Yes.
So what we'll do, we'll say our h of x is the y value there, because this is h here, this thing. So our 0, which is this part, is equal to m, which is what? Minus 1 minus 0 all squared.
Plus 2.
Plus 2 into minus 1 minus 0 minus 3
Plus 2.
plus q. Are you with me?
Yes.
So our 0 is equal to, this is minus 1 minus 0, this is 1, right?
Yes.
So minus 2 minus 3 plus q.
Q.
So looks like this is minus 4 in total. Or 0 is equal to minus 4 plus q, is it?
Yes.
Therefore, our q is equal to 4. Do you understand?
Yes.
Which kind of makes sense? Because if your function was 4 units below, to get it to sit up here, you have to push it up 4 units.
Yes.
Do you understand?
Yes.
Because 4 is the y shift, so you add it upwards. So it's a vertical shift, you add it in this side here, but they moved it to that side. So in short, you can say this function is moved, is shifted 4 units upwards and 1 unit to the left. That's what they did.
Yes.
Actually to the right and 1 unit to the right. So that it sits there at 0. And that's how to do it. Or you want us to do the other way?
Yes.
Okay. I'm not going to clean that one. Just going to clean this part. I'm supposed to clean this. So this is 4.7, right? They said h of x is equal to f into m minus x plus q, right?
Yes.
This is what they said. So what do we do? Because we were told about this x-intercept, which is a turning point, try to write your f so that it talks about turning points as well. Do you understand? So try to express this in this form. This is 4.7 as well. Y is equal to a into x minus p all squared plus q. Do you understand?
Yes.
So to move from this to this way, how do we do it?
To move from.
If you want to write this thing want to change from writing this way to writing it this way,
Oh, we have to complete.
we complete the square. So let's complete the square. It's okay. F of x is equal to what? X squared plus 2x
Minus 3.
minus 3. Rule number 1 for square, make sure the coefficient of x squared is 1.
Yes.
It is 1.
Yes.
Rule number 2, take the constant to the other side.
Yes.
So we're going to have f of x plus 3 is equal to
X squared
x squared
plus 2x.
plus 2x. Rule number 3, you add half of the coefficient of x and square it both sides.
Both sides.
Yes. So we're going to have f of x plus 3 plus half of 2,
1
which is 1 all squared, is equal to f of is equal to
squared.
x squared
plus 2x.
plus 2x plus 1 all
All
squared. The next thing, just factorize this side.
Yes.
So this side you're going to have f of x plus 4, do you agree?
Yes.
Is equal to factorize this, take 1, take the sign. So it will be x, it will be what is inside there,
Plus
but
1.
it's going to plus 1. Actually take it with its own sign,
Yes.
right?
Yes.
All squared. Is it like this?
Yes.
Then you just solve for x again.
Yes.
So what you have, your f of x is equal to what? X plus 1
Plus 1.
all squared plus
Plus minus 4.
minus 4. This is your f of x here. Do you understand?
Yes.
Are you with me?
Yes.
This is your what? The f of x. So now the only thing to do once you are here is to now express h of x as this thing, which is what you've done down here. So okay, h of x is equal to f at x minus x, right?
Yes.
So it's going to be left bracket in the place of x. Where is it? In the place of x, we're going to put this m minus x, this thing. Are you clear?
Yes.
Going to put this m minus x in the place of x. Are you with me?
Yes.
That is the place of x, and then you say
Plus 1.
plus 1 all squared
Yes.
minus 4, and then you add that what? That q at the end. Are you with me?
Yes.
So what you have here, you have some sort of if you want, you know that if you want to find your x coordinate of the turning point, you equate that thing to 0 and solve for x.
Yes.
Are you with me?
Yes.
Don't you do that?
Yes.
If you want to find the x coordinate of the turning point from a function written this way or written, where is it? This way, you say x minus p is equal to 0.
Yes.
Then you find the x coordinate of the turning point. To find the y coordinate of the turning point, is y is equal to q. So in this case, if you want our x coordinate of the turning point, what will we say? M minus x
Plus 1.
plus 1 is equal to 0. Let's take the x to the other side. So we left m plus 1 is equal to
X.
x. Which is that x is our what? That x we solved there is the x coordinate of the turning point.
Okay.
Are you clear? Because I'm saying,
At.
if we solve this x here,
Yes.
if we say x minus p is equal to 0 and solve for x equal to p, what is this p?
Turning point.
Is the x one? It's the same thing.
Okay.
It's the same thing. And we know now the turning point. What is the turning point? The x coordinate?
0.
0. So, which means your m plus 1 is equal to?
0.
Therefore your m is equal to?
Minus 1.
Minus 1.
Oh, they got the same thing.
And then if you want the what is the y coordinate of the turning point here on this one?
0.
On this one, on this equation, how would you tell me what is the y coordinate?
Or substitute.
No. Don't find the real one. What I'm saying is, if you have a function written like this, how would you find the y coordinate of the turning point? Timos, you said you would find the x coordinate of the turning point like this.
Yes.
So how do you find the y coordinate of the turning point? I said, to find the y coordinate of the turning point, you always equate this to that. It's going to be y is equal to whatever is remaining inside, whatever that you didn't use when you find the x coordinates. So it's y is equal to q. The same way you find the asymptotes of all those functions. So if you want the y coordinate of the turning point of that thing, it's this thing here. So your y coordinate of the turning point, of the turning point is equal to minus 4 plus q is everything else. Do you understand?
Yes, I do.
Then, you know what the y coordinate of the turning point, what is it?
0.
0 is equal to minus 4 plus q. Therefore, your q is equal to 4. There is it. So, you could have approached this way or that way. I always prefer this way because it's much better looking than this.
Yes.
And I think we're done with these questions. Hope it does make sense to you as it does to both of us. Any questions?
No questions.
Yeah, then we're done here.